Greetings to all of my Math8A students out there. Today we're going to be looking at section 11.6, the sixth section of chapter 11. We're moving on through, and today we're talking about adding and subtracting rational expressions. And when we talk about rational expressions, I've got some examples of some rational expressions up here. Remember, rational just means ratio-ish, fraction-ish, kind of. And so you've been adding and subtracting rational expressions for years, right? But today what we're going to do is take a step further, and we're going to, instead of just basic fractions with numbers in them, we're going to do rational expressions that have variables mixed in them. So instead of 1/9 plus 2/9, we're going to do something like x plus 8 over 2 plus x over 2. Something like that. Or some more complicated things as well, which we'll look at in a minute. But before we look at the more complicated stuff, let's look at the simple stuff. You know that when you're adding fractions together, when you're adding rational expressions together, and they already have an existing common denominator, it makes your life much easier, because if you have a certain amount of ninths plus another amount of ninths, you just have more ninths. And you didn't have to find a common denominator or create a common denominator. You just had to use the common denominator that was already there. Now, you do have to be careful at the end here, because you're not done unless your answer is in simplest form. So we always want to make sure that we simplify any answer, right, that we give when we're dealing with rational expressions. Now, it can get a little bit more complicated, like 1/9 plus 2/5. We do not have a common denominator. So typically what we do in this kind of a situation is we just take the ninths and we multiply by fifths, and we take the fifths and we multiply by 9 over 9, so that basically we turn both of them into 40/5. And now we have the common denominator that we desired, and we can just proceed accordingly. So you can create common denominators by just multiplying both denominators by each other, basically. And of course, if you multiply the bottom by 5, you got to multiply the top by 5. If you multiply the bottom by 9, you got to multiply the top by 9. But this is elementary stuff. What I want to show you a little more reminder of is you don't always have to multiply this by 9 over 9 and this by 6 over 6. What you can do sometimes is look for what we call the least common multiple. So what's the least common multiple of 6 and 9? It's not 54. It's actually just 18. So if I want to turn this into 18ths and 18ths, I don't have to multiply by 6 over 6. I can just multiply by 2 over 2. And that's going to make my life simpler. Now, could I have multiplied by 6 over 6 and 9 over 9? Sure, you could have done that if you wanted to. But it's going to make life easier if we look for those least common multiples. And so now I've got 17/18. And I don't need to simplify or reduce when I do it that way. If I had done it the other way, if I had done, sixths over here and ninths over here, then I would have had something over 54, and I would have had to simplify or reduce to get to here, which is okay. That's fine. There's nothing wrong with that. But we do always want to make sure that whatever we do, we give our answer in simplest form. Now let's get to what you're going to really have to do in section 11.6, and that is not just deal with numerical fractions, but rational expressions that have some variables mixed in there. So what we're going to do is we're first going to look and see, do we have a common denominator or do we not have a common denominator? In this case, yay, we have a common denominator. So how many halves do we have? Well, I have a certain amount of halves, right? And I have x plus 8 plus x. So I'm just going to add that all up. But of course, I want to simplify that. So x plus 8 plus another x is 2x plus 8. And here's where, remember, again, we really want to make sure that we give our answers in simplest form. This can be simplified because 2x and 8 can both be divided by 2. So our final answer on this one should be x plus 4, not this. Hopefully that makes sense. Yeah? Okay, now let's try one that doesn't have a common denominator. Let's step it up and try to do this. X over x minus 3 minus 3 over x plus 2. All right, so I think all I can do in this scenario is the same thing that I did here. I multiplied the 9 by the 5 and the 5 by the 9. I'm going to multiply the x minus 3 by x minus 2. No, x plus 2, sorry. And if I multiply the bottom by x plus 2, I got to multiply the top by x plus 2. And then I want this denominator to match that, so I got the x plus 2. I need to multiply that by x minus 3 so that now we have a common denominator, right? But if I multiply the bottom by x minus 3, I'm going to have to multiply it by that 3 by x minus 3. And then let's see what that's going to give us down here. On this top, I'm going to have x squared plus 2x. On this top, I'm going to have 3x minus 9. Right? And do I need to FOIL, 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 FOIL? No, I think I can actually just keep it like this for now. But what was happening in the middle of all of that? Subtraction. And this is where some of you are going to run into some problems. It's this whole thing minus this whole thing. So you need to make sure that we're not just going to do 2x minus 3x, but we're also going to do minus minus 9. So I've got x squared. 2x minus 3x is 1x. And then minus minus 9 is plus 9. Raise your hand if you think maybe that's a potential landmine that you need to be careful about avoiding. And then finally on this one, I've got my new denominator with both of the expressions there. And there's one thing I need to check here. I need to check and make sure that I can't simplify this. Doesn't look like I can simplify it. But could I maybe? Could I factor this trinomial? I don't know. And how do you make 9? Well, 9 would be 9 and 1. Can't do magic numbers with that. 9 is 3 times 3. Can't do magic numbers with that. Okay, so we're good. This is in simplest form. And you might think, why did Mr. Marbut just go through the trouble to talk about maybe trying to factor this trinomial? Well, what if you could have factored this and one of these binomials was one of the factors? Then you could have simplified it. Simplify, simplify, simplify whenever possible. Okay, so do you think you could handle that problem? I think so. We just went from here to here. And we did it by trying to create a common denominator where we didn't have one to start with. Okay, let's try that one more time. And we're going to do a problem that's a little bit more related to this. Now I'm going to do y over y minus 3. And then I'm going to do minus 2 over, watch this one, y squared plus y minus 12. Complicated. Complicated. Now I could just multiply this whole thing by y squared plus y minus 12, y squared plus y minus 12. I could multiply this whole thing by y minus 3 over y minus 3, but I'm not going to do that. Why am I not going to do that? I'm not going to do that because this trinomial right here is factorable. This is actually this. Think about that for a second and make sure you know where I came up with that. Magic numbers. 4 times negative 3 is negative 12. 4 plus negative 3 is the invisible 1. So, look, they already have a y minus 3 in common. So I don't need to multiply this by that whole thing. All I need to multiply this by is y plus 4 over y plus 4, right? And this one doesn't need to get multiplied by anything because now the denominators will match. So y plus 4 times y is y squared plus 4y over, and I don't even need to put minus and another fraction here because I have a common denominator, so I can just put minus 2. Because the minus 2 was already over all of that. And finally, I'm just going to look at this and I'm going to ask myself, is there any way that this might factor and cancel with one of those? So let's check the magic numbers. 2 is either 2 times 1 or 1 times 2. I don't think there's any way that you could do magic numbers here. So this is your final answer, unless I'm missing something on that, but I think that's it. And if you wanted to, you could refoil this out so that it looks more like that, and you could have a trinomial over a trinomial, or you could leave the denominator in factored form. Either way is totally fine. I've just got one more problem to challenge you with. And my last problem is 14r over 9 minus r minus 2r over r minus 9. I want you to take a pause for just a second, look at those two rational expressions, and ask yourself, do they have a common denominator? The answer is no. 9 minus r is different from r minus 9, but there's a trick here. Remember the trick. R minus 9 times negative 1 would be 9 minus r. So we can basically make this into a 9 minus r by factoring out a negative 1. Or, in other words, minus minus is now going to just become a plus. So really all I have here is 14r plus 2r, which is 16r. Over 9 minus r, and I'm done. See how easy that was? So I just wanted to show you that example because it didn't look like they had a common denominator, but they had a very close to common denominator that if we remember that negative 1 trick, we can make them into a common denominator pretty quickly and pretty easily. And that is it for section 11.6 on adding and subtracting rational expressions. Hopefully that made sense. If you need to pause or rewind to let any of those problems soak in, feel free to do that. Let me know if you have any questions, and I will see you next time.